motion. Uniform motion means uniform velocity motion. So if I ask a question, and that means casually to any student, give an expression for a body move the uniform velocity or bodies move the uniform motion. You will say, sir, V is equal to U plus AT. S is equal to UT plus half AT square. E square is equal to U square plus 2S. This is the usual answer I get. Wrong. When a body moves with the uniform velocity or the body is executing uniform motion, the equation is xt is equal to x0 plus v into t. Then a question arises, then what is v is equal to u plus a, s is equal to ut plus half, this is u square plus v. Those are equations of motion of a body executing linear motion with constant acceleration. In this case, this is the equation of a body which is with the uniform velocity. When a body moves at uniform velocity, what is the equation of the motion of the body in linear motion? That is equal to xt is equal to x0 plus v into t. What is x0? X0 is the position of the body when time was 0. When time was 0. What is time 0 means what you understand? When you look at the motion of the body, that is what is collision time. Your observing time starts with the t is equal to 0. Then what is t? That means the final position when reaches your observation. That time is what is called final time. Okay. So xt means this is the position of the body when the time is t second. X0 means initially when you look at the body, what is the position of the body from the origin? It is not necessary that body must move from the origin only. Body may be starting from a position away from the origin. So in that case, there is already a distance or displacement of the body from the origin. That is what is flexible. Body is not starting from the origin. Right? If the body is starting from the origin, then x0 is equal to 0. In that case, what you will write the equation? Then x is equal to only vt. So if the body starts from the origin, then xt is equal to simply vt you will write. So if the body is not traveling, not moving its motion or executing its motion from the origin, but body starts from A or A is away from the origin, then already the body has some displacement. This is the displacement of the body at t is equal to 0 seconds. Now the body moves from, now you look at the body and go on, let it go on moving and reaches at the point B. Then what is the final displacement when time t is equal to t second? That is equal to xt. This is equal to x0. So general expression for a body moving with uniform velocity is xt minus x0 is equal to v into t, or xt is equal to x0 into x0 plus v into t. So this is about. So next is uniform motion. The velocity always remains a constant. Velocity of the body always remains a constant in uniform motion. Remember that. In uniform motion, velocity is a constant. If you draw a velocity time graph, of a body executing uniform velocity, that will be a straight line parallel to the x-axis. Right? This is the condition. So this is VT graph. VT graph means velocity time graph. Velocity time graph is a graph that is drawn with time along the x-axis and velocity along the y-axis. Suppose when you look at the body has a velocity already. Suppose you set a toy car on the table and it is set to move and you were sleeping, your eyes were shut. Right? All of a sudden, when you open the eye, then the body was seen moving. That had already velocity. That means at at 0 time also the body has a velocity. Am I correct? 0 time, the velocity is this one. After 1 second, this is 0 time. After 1 second, you are again seeing the velocity of the body, because the body should be uniform velocity, means velocity must always remain a constant. The same, suppose this is 10 meters per second, the body was moving initially. Then you just open the eye and see the toy car was moving in a straight line, and that had its velocity is equal to 10 meters. Then you look at the watch. When it is 1 second, again you see the body has the same velocity. And when it is time 2 seconds, then also you will see that the body will have the same velocity. The body is getting displaced equally in equal intervals of time. That means the velocity always remains the constant. So this is 1 second and this is 2 seconds. 1 second also the velocity is same. 10 meter, 2 second also velocity is same. Like that it goes. Therefore, when a line is drawn, that will be parallel to the time axis. When a body moves with the uniform velocity, then the velocity time graph will be a line parallel to the time axis. Parallel to the time axis. Am I correct? This time we can take as equal to T1. This time we can take as equal to T2. Right? Okay. This is the velocity. So this is the velocity. So T2 minus T1 is equal to T. That means final time minus initial time is equal to T, you can write. This is velocity. When you take the area of this, this part is velocity. This is 10 meter. This also 10 meters per second. This also 10 meters per second. And this is the time axis. What is the time taken? Total time taken from the T1 to T2? That is T2 minus T1. T2 minus T1 you are taking as T2 minus T1 is equal to T6. So every time the velocity is same only, therefore this also be meter per second. Okay. Then if you take the area of the VT graph, is equal to what? That means this is base into altitude. That means that is equal to velocity into time. What is velocity into time? Velocity into time is displacement only. Velocity into time is equal to displacement. So when a body moves with the uniform velocity, then the displacement of the body is the area enclosed by the body. Right? When traveling from T1 to T2, the body is traveling from T1 to T2 with the uniform velocity. So within this time, what is the area of the velocity time graph that you have drawn? That is equal to displacement of the body. So when a body, the displacement of the body can be obtained. Displacement of the body can be obtained by taking area of the velocity time graph. So this is a very important term. Area of the velocity time graph is the displacement of, once again I speak, the area of the velocity time graph is the displacement of the body during that time interval, right? This is velocity time graph of a body which is moving the uniform velocity.